Hit record. All right, students, ladies and gents, I have an extremely special guest across an ocean, and we met through, which was great. One of my students, Rashid, did a project that ended up talking about this wonderful human. We're grateful to have you. Dr. Isu, we're thanking you so much. You're 6 hours ahead of us, so thank you on your holiday for talking to us. And how was your morning going? All's well?
Good, thank you. Everything's great over here. It's a pleasure to be speaking to you this afternoon. It's a bit cold today. We're just about hitting like winter here in the UK, but no, really excited to have this conversation and speak to you and yeah, and just chat.
Oh, I love it. We can't wait to learn about your story in that. So, Dr. Isu, if we could start, let's start with kind of the big picture. Could you talk about what your job is currently and kind of what your day looks like? And then from there, we'd love to kind of hear your path of how you got there. But what is like your official job that you do, and what does that look like day to day for you?
So at the moment, I am the Smart Assets Lead at BRE. So BRE is the Building Research Establishment.
Okay.
It's been around for over 100 years, and it's the world leading research center for the built environment. So knowledge generation. So most of the times when you have policies about various things within the built environment, by built environment, I mean your roads, your infrastructure, your houses. There's a whole sector around that and the construction industry. So most times to be able to deliver policies and standards about how you want things done, there's a whole lot of research that happens within the background that informs those policies. So that's kind of the space where BRE operates. It used to be a government ministry in the past. It's privatized at the moment. And now I currently work on a project called Construction Innovation Hub, which is a government funded project to look at how we could better use technology and the growth in digital space basically to improve how we currently build buildings and how we currently operate and use them to be more energy efficient, to be more sustainable, and to just have a better and give occupants a better satisfaction within the space. So as Smart Assets Lead, I'm looking at how we could use sensors to collect data. So it's already being done in various places. People have like smart systems in their homes already. So people would know Alexa, for example, that controls quite a lot of things, your Nest systems and your doorbells, this kind of stuff. But my role looks more at non-residential buildings. So when you're bringing these types of technology into office spaces where you don't know the resident of that building, it's anybody, several people coming through each day. So what types of sensors could we use? Are the sensors that are currently on the market up to standards? Because there are currently no standards around that govern how these sensors operate. It's kind of like, because it's an emerging technology, Internet of Things and these sensors. So there needs to be some way of verifying the accuracy of these sensors and verifying the information they measure, but also not just looking at the benefits, looking at the risks that are associated with these devices. So for example, can somebody infer when somebody is present or when somebody is absent from their office space if it's a single office unit through, for example, their air quality sensor? So you could measure and monitor the CO2 levels. Could that information be used to infer how productive somebody is? So if like who gets access to the data when it's collected from the sensors? It's one thing for the building to be operational and to be working effectively, but who gets visibility of that data and what is done to that data? But just also the process of how that data is collected is not well managed at the moment, and the issues around cybersecurity. So yeah, it's the whole package around it, but specifically looking at the performance of these sensors and how we could improve the experience people have of them. We believe that technology is a good way, is an advancement. In the past, the way we've designed buildings is it's just been the same rule for every type of building. And what we're seeing is that buildings cost a lot of energy, they consume a lot of energy because they're designed for the maximum capacity, and that maximum capacity never actually occurs and never actually happens. So having sensors measuring how people are using a building can then improve future designs down the line, so we're not wasting as much energy and resources as we currently do. And this extends to other aspects. So other stuff the project looks at, but not specifically my team, is off-site construction. So could we be manufacturing buildings like we do for our cars, our airplanes, or what come on with that it happens in like a plant somewhere and then it's brought to its destination. Could we be doing that for buildings as well? And then what knock-on effect does that have on the current job market and the current skills and training that young people have? Are young people well equipped for those types of jobs where we're moving from where it's a craft like it is currently now in construction for every building you build? And is this the right time to be making those types of leaps? So those are some of the stuff on areas I currently working within BRE, and I find it very exciting and interesting.
This sounds like a humongous question or problem that you're trying to solve. Does that ever get overwhelming for you and your team?
Yeah, sometimes. And just recently, we've actually had to really focus our efforts because, yes, it's a government funded project, but it's not forever. We have funding for a set amount of time. So what can we genuinely achieve within the period we have for our funded project? And so we've streamlined it into 7 work packages, which we will be taking forward as part of the team that I lead. And the first one is looking at the use cases. So what typically happens when people deploy sensors in their buildings is, oh, I like that sensor, I'm going to get that. Or the sensor manufacturers pitch this particular sensor to you, the consumer. And what we're trying to do is to generate use cases for industry. So where if you want to know the CO2 levels within your space and what that information could be used for, then consider measuring this particular thing. So I think once the use cases are not understood, it's very difficult. You have people having sensors that do the same thing, but by different manufacturers. So trying to streamline that process of how people like actually choose sensors, how designers and consultants who design buildings choose those sensors. I think once the use case is there, it's easier to make the financial arguments for it. And we want people to move away from only looking at the cost of things to looking more at the long-term benefits for the individuals within this building, but also most importantly for the environment. How sustainable is that project while it's being built and after it's been, so throughout its entire whole life cycle. After the use cases, we're also looking at in work package 2, the actual IoT devices. So IoT, I keep saying, is the Internet of Things is what it stands for. And there's a general term we use for the sensors that measure CO2 VOCs in your building. So carbon dioxide and then volatile organic compounds. So at the moment on the market, you have sensors that people pitch their sensors. Sensor it can measure VOC, it can measure particulate matter. But traditionally, how you would measure for those things within a building varies. So the standardized ways when a project is completed and you have the specialists who come in and assess the building before they hand it over to the owners of the building for people to then occupy. But now you have people making sensors saying one sensor could measure all 3 things. So part of what we do at BRE is putting a varied range of sensors from off the market through a series of testing within our labs and within our chambers, just to see how effective and how accurate the data you're collecting. Because if you're expecting people to make decisions based off of these data, you need to give people the assurance that it is correct data, it is correct information. So that's what work package 2 looks at. And then work package 3 looks at how when you get the data from the sensors, how it is managed and how it is used in something we call a digital twin. So that's what the UK is moving towards, where for every physical building, every physical asset, every road, every railway track, there is a digital representation of it. So you could start to make decisions and plan for maximum capacity ahead of time when you have a digital representation of your asset. So Power Work Package 3 is looking at how those come together. Currently, when I install a sensor in my house, for example, I will call it Temp 1. So let's say it's measuring temperature. Somebody else could install it in their own house and call it TX1. It's the same thing that happens in buildings. Depending on who the consultant and who the designer is, there is no convention for how we name these devices because there has been no need for it in the past. But increasingly, if you want to start getting like especially in like think of a multi-floor office building, and you're thinking of having a digital twin of all your assets located in different parts of the country, it's important that there's a naming standard so that if somebody sees TX wherever they are, they know that that stands for a temperature sensor. So part of what we're doing is looking at the naming of that, so that it's one thing to have data, it's another to make sense of what that data means. Because if it's just data, it's of no use to anyone until someone is able to make decisions from that particular information. And then work package 67 looks at security, so cybersecurity, how you protect the digital twin, and work package 7 explores further industry challenges and gaps that have been identified around skills and training. Because we in the UK are facing a real shortage within the construction industry. Not many young people are applying to this industry, because fair enough, in the UK, it's still very ancient. I don't think the construction industry has moved on as quickly as other sectors like manufacturing, for example, or the tech sector, or yeah. So it's looking at those skills, because a lot of the stakeholders we have, which is other companies and other people within the industry, they talk about the challenge about recruiting young people and then exciting them about the opportunities that are available within the sector. So part of that work is looking at the existing academic curriculum that we have here in the UK and seeing how we can optimize what the content that students are learning, so that they're well prepared for these, shall I say, technological transformation that's happening within the sector. But yeah, in a nutshell, that's the work packages we're currently on. So it helps manage it a bit more now and focus efforts for the period we have.
You bring up some incredible points, and I know we'll keep this short. I could talk for hours to you. I love all this stuff. But you bring up like all that data. Who gets to use it? Where does it go? Could it be used against people eventually or in a good way? I just think that was a great big question to bring out there, that the world of digital and data, that security is a huge concern, and something that it's nice to hear that you guys consider that too. So thank you for bringing that up. Something I'd like to talk about. So you're solving these big problems. What does it look like during a work day for you? Are you doing video conferences? Are you crunching numbers with computers? Are you working with a team? What does it look like just as a human for you through your eyes for a day?
So my day is at the moment, because of like COVID, because of the pandemic, I've been working from home since March 2020, and this is December, and it doesn't look like we're going back into the office anytime soon in the new year. I'm very fortunate to still have a job, and because quite a lot of people have been made redundant or have lost their jobs in this pandemic. But before COVID, my typical day, I'd go into work in the morning at 8:45 to start for 9, and I work in a team. And I think that's, for me, that's the best thing about engineering, is that you always most engineering roles, engineering is about solving problems. So most times you're not solving it on your own. It's best to like have a team around you and be able to bounce off ideas, and eventually the final solution you have is like a refined solution and much better than what you could have come up with on your own. So I do have a team. As lead, I'm responsible for a number of staff on my team, but I also have a line manager as well that I report to as well. So it's typical day will start with tea and coffee in the morning, and then it's mostly meetings most times. So we have something called a daily scrum. It's like where we all stand up and say in 15 minutes what we did yesterday. So basically your progress on what you did yesterday, what you plan to do today, and if there are any blockers. So sometimes a blocker could be if I don't finish a particular part of my task, it now affects the next person. Or if I haven't made a decision on something, it's a bottleneck for the next person. So we always start with the daily scrum. But after that, my tasks include like meetings with various stakeholders. So sometimes it could be manufacturers of the product who are telling me about their product, or sometimes it could be with our testing team who are giving me feedback on the sensors and the performance of the sensors that they've tested. And then most times there's a lot of reading, for the sector where I am in, technology is always advancing. There's always something new and you have to keep on top of it. So a lot of reading is what I spend most of my time doing, knowing what's happening, not just in the UK. Yes, the solutions I'm looking at are for the UK, but what are other parts of the world doing? What are other research teams elsewhere doing? Just a good way to keep on top of that. And then most times I would spend it in the lab, so where we're doing the testing, or in one of our demonstrators. So on our estate in BRE, we have a lot of test facilities. So we have a smart, so for example, for smart homes, we had a smart home where we kitted it out with all the latest gadgets, and people just test them to, shall I say, destruction almost. So what kind of errors could happen with them? I remember when they tested, and someone was able to, so for security, someone was able to get access to the floor plan for the entire building through the smart Hoover, or the smart, I call it a Hoover, but it's actually a vacuum cleaner, basically. So that was interesting. Another one was able to gain access to like the computers and stuff through the electric kettle. So those types of testing is what typically happens. But for my own end, most times there'll be sensors being installed. So I'd have to oversee that process, but then also seeing the progress of the digital twin. So within our team, we have software developers and software designers and digital twin and data architects within our team, who take the data that's coming from these sensors and continue to build on our model of the building. So we have a digital model, it's called BIM, so a building information model of our building, and seeing where we need to update it. So it gets very busy, and by before I know it, I blink and it's lunchtime. And then I continue with something else, like, or it could be a meeting, or it could be further reading, or just continue from where I stopped on my previous task. Now, since lockdown happened, obviously I'm not on site. So I've been working from home. So we still have the daily, virtually, the daily scrum where we talk about what we did the previous day. It's actually more important now. This is a good way for me to start my day, because it connects me with the rest of my team and just checks in and it helps me know where everyone is at. And then most times, and so far, we've been working on other work packages that don't involve us being in the office. So we've really been focusing on the digital twin and making it like a true representation of the physical asset that we have on our estate. And we have a series of demonstrators, because at each checkpoint, obviously the people who are funding your project want to know the status update on what you're working on and how it's going. So we've had quite a few of those, especially in the pandemic, because it helps people get an understanding whether the project is going ahead or whether elements of it need to be changed because of the pandemic. But yeah, I really enjoy what I do. I don't know if it comes across, but no days, like I enjoy having like a problem and having to think about how to solve it. And I like that the burden is not just on me. Yes, to some extent is on me as a lead, but I like that there is a team where I can bounce off ideas and have these conversations and come up with a solution together. And I think that's something you don't get in every profession, but you definitely get in engineering. It's very collaborative, and it's really about teamwork, and I really enjoy that. So when you succeed together, it's always happy, obviously. But also when it doesn't go right and you fail, you're not alone. It's not an individual. You fail together. So it's kind of spread out, and the same way the chair is spread out as well. And I really like that very much.
That's great.
But yeah, that's in a nutshell.
Well, thank you for sharing that. I could totally see it too. Seems like you guys are constantly learning, working together, and solving problems, and kind of. I need you to do this, so I can do this next, and that. Like that's got to be an incredible thing to be able to balance all of that. With that being said, maybe we could talk about, are there any skills with engineering or work in general, or advice or that you would give to students, like, hey, if you're interested in engineering, these are some things you should know how to do or be prepared to do or should look into. And it could be anything from working with people to specific programs, whatever. Is there anything that comes to mind off the top of your head that you would give?
Yeah, definitely. I think the interpersonal skills. I think growing up, obviously, I was in the science class. I was really good at maths. I enjoyed numbers. Didn't like any of the other social sciences, just purely because there was opinions. So I like the fact that when I add 2 plus 2, it's 4. You're not going to say, but if you look at it from this perspective, no, there's no perspective. It's 4. So I like those type of subjects where there was no debate about things. Facts are facts, and the figures are the figures. And increasingly, what I've realized is that working in engineering, most times, and most of the young people that come through, we're very heavily focused on the numbers and the technical aspects. We want to know all the principles and physics and everything. It's very important to have that background knowledge, and it will help you. But I think something people need to really develop is the interpersonal skills. So how are you in team settings? If it's something you don't enjoy, perhaps it's something you need to look at, because you could struggle if you go into a career in engineering, if you don't have those interpersonal skills, being able to relate with other people, being able to communicate effectively. I think that's one I'm still developing even now in my career, is communicating effectively, because sometimes the instructions I give and the output somebody else makes of that information I gave to them, it's sometimes it's completely different, and it's like I wasn't seeing it how they've interpreted it clearly. So there's a communication problem there. Most times it's on my part, and I'm working on it. So definitely the interpersonal skills, I think, and good ways to like help you develop that is most times it's things outside of the classroom. So I didn't have that in school, but when I came to the UK, so I grew up in Nigeria, I didn't mention, and I came here to study for my undergraduate. And it's through volunteering on campus. So being involved with like Engineers Without Borders, where you get to meet students from other disciplines, not just yours, and athletics and stuff like that, where I actually met other people and was able to develop those team skills, and that it wasn't centered around the coursework or a particular academic task. It was more other things like encouraging or enthusing people about science, and just talking about what I did. So confidence was another one that comes with time. I was very shy, very reserved when I came to UK, and it was my personal tutor who actually advised me, like, if you want to go into research, you should be able to stand up when asked to speak about what you do. And if you're so afraid of speaking and about sharing your knowledge, you're going to struggle. So I started going to schools and to primary schools to talk about like what I did. I remember trying to explain my PhD to kids in the primary school here. And they're looking at me because I was using all these big words and all these terminologies and abbreviations. And sometimes, again, it comes down to communication. It's like sometimes you need to consider your audience and really simplify what you're trying to say. And then at the end of it, I remember one kid saying, so you're like a doctor for, so my research was in wind turbine blades. So how we can detect damage using sensors on wind turbine blades that generate electricity. And I remember saying about how, the sensors are going to do this and do that, and they'll be able to tell us when a blade is damaged. And the kid literally just said, so you're a doctor for wind turbines? And I was like, I'm not a doctor yet. I'm still a student. He was like, no, like the blades can't speak. So you're like the doctor who's going to figure out what is wrong with the blade. I had never thought about my research in that, like, no, simple level. And so that was an experience. But definitely, I think the interpersonal skills. Something else I'd say is never be afraid to ask for help. I remember when I came to the UK, I used to be so shy to ask questions in class because like I felt like everybody else got it. I didn't want to look like the one who didn't get it, even though I didn't get it. But the thing is, if you don't ask for help, you will struggle and you would never get better at that particular thing. So I grew more confident, and by the second year, even if I didn't ask in class, I was quite comfortable meeting the lecturers to ask them on the side, like, what do they, like, could they explain things better to me? That helped. Also, my peers as well. Sometimes I feel like because we're learning it together, they even have a different perspective to the teacher, for example, or to the lecturer. And it's a lot easier to understand it when they explain it to me. So definitely always ask for help, and don't be, I always say there's no such thing as a stupid question. There really isn't, because by asking is the only way you're ever going to know about things. Yes, there's Google, but sometimes it helps to get those initial pointers from somebody to then know what to go and research. But I think the biggest advice, to summarize, is definitely the technical knowledge is very important, and keep practicing that. But also look for opportunities to develop the interpersonal skills you need to be able to work in an engineering environment. And then just be proactive about opportunities. So don't overthink it. So whether it's a competition you want to enter, I know most people have the mentality like you're in it to win it, but sometimes you could learn a lot from just participating in the process and putting yourself forward for things. I would definitely recommend that, whether it's volunteering or whether it's a competition or whether it's an award. Yeah, those are my main advice I would give. To the
Thank
students.
you. I thought that was wonderfully said. Yeah, experiences really do make a difference, even if, like you said, they didn't particularly relate to your specific job, but volunteering, it just, you learn life skills in that. So thank you for
Yeah.
that. Well, I did want to end one last thing then, because I know that you're on holiday and I appreciate your time. To our celebrity engineer here, all the way from the UK. But really quick, you were born in Nigeria and then you ended up now in the UK, and
Yes.
that's by no accident, of course. So, what took you from your home in Nigeria to the UK and ended up in this world of engineering and helping the environment?
Yeah. So I was born and raised. I was born and raised. Sorry about that. I
That's
was
okay.
born and raised. I was born and raised in Nigeria, and and when I was growing up there, we had like frequent power cuts. So and that's still common till this day. So
Okay.
we don't have constant electricity. There's 200 million Nigerians. For those who don't know, that's how many we are.
Okay.
So demand is always going to outweigh supply. And but then adding on other factors to that, like for example, poor management of infrastructure and just playing out corruption, basically. So we never had like power growing up. I remember going through the stages, and that was like a thing, like where you aspire to go through the stages of access to electricity. So when we're little, my siblings and I, my parents used to make sure we did our homework as soon as we came back from school. And because if it got darker, we'd have to use candle light to do our homework, which is
Mm.
not very good for your eyes, especially when you're growing up. And then from candle, my parents were earning enough for us to get kerosene for lanterns. And then they'll put those on when it got really dark just so that we could see our way to bed. And then eventually they got rechargeable lamps that they'll take with them to the office, charge it and bring it home for us, till the ultimate goal of getting their own diesel generator. Now the problem with that is like every single person aspires to have a diesel generator in their own home. If you think about the noise pollution, but as well as the air pollution everywhere, is just blasting really loud. And I loved watching TV, so it didn't help that my favorite thing to do was being interrupted by power supply. So from that very early age, I remember I used to get really frustrated by that. And my dad said that it's like electrical engineers who, he said it was electrical and chemical engineers that work in the power sector. But I'm from the south of Nigeria, a town called a city called Calabar. I live in Calabar, and from the state is called Cross River State. And down south of Nigeria, we do have oil. And I knew at the time there was a lot of like explosions on gas and fields and stuff like that. And I knew, I remember saying to him, like, I don't want to do anyone that involves explosions. And he was like, chemical engineers tend to do work around oil. So I was like, yeah, I'm not going to do that. I'm going to do electrical instead. And yeah, that was where I think I was around 13 around this time. I'd gone through phases. I wanted to be a pilot at one point. But yeah, I really settled on electricity because I just think of all the things we could achieve if people had constant power, how much our lives could be easier, how much easier our lives could be, and how much money we could generate for the economy if businesses didn't have to weigh in that factor of like additional costs for electricity. Because when you have your diesel generator, you have to constantly keep fueling it. And it costs money, but there's also damage to the environment as well. So yeah, I started studying, and it helped that I was good in maths. I wasn't very good in physics and the chemistry, but the moment I made the decision that this is a step to get to where I want to be, I had to take those subjects seriously. And so I got tutors to help me with those particular subjects. Never got quite great in chemistry, but I managed to improve my grades massively in physics. And when I got to A levels, I was told that I could choose, I had to have physics and maths to come to the UK, and I could choose a third subject. So I chose geography because I'm quite interested about the environment, about how, like, I used to be so geeked out about how rocks are formed, and like it used to blow my mind. And those sorts of stuff, like till this day, really interest me. And so, yeah, I did maths, physics, and geography for my A levels. I was meant to go to university in Ghana, which is not far from Nigeria. It's like neighbors. But they weren't going to take me at the time because I was 16 when I finished school. I had to be 17. So my parents sent me to this A-level school for a year, just until I was 17. So then I could then go to Ghana. And the reason why I wasn't going to go to university in Nigeria was because we have frequent strikes. So sometimes the lecturers are not paid enough by the government, and so they go on frequent strikes, or students go on strikes because the fees are too high for the value of the education that they get. And a 5-year course could easily become 8 years at the university there. Whereas in Ghana, it was very stable, and your 5-year engineering course was your 5 years. But while I was at the A-level school, my teachers started talking about the UK and like saying, like, encouraging me to apply to the UK. And yeah, I applied and I got an offer to study there at 2 universities. I didn't get my first choice because I did accelerated A levels. Normally, you do your A levels in 2 years, not 1 year. But because of my circumstances, which I explained to you just now, was why I was doing it in 1 year. But I managed to get into Loughborough University, which was like the top 4 for electronic and electrical engineering. And I just ran with it, to be honest. I was so grateful that they were willing to, they were willing to concede and give me like that opportunity. But I had to downgrade from the program I applied for. So in the UK, you could do an MEng program, which is a master's sandwich program, or a bachelor's program. So I had to downgrade to the bachelor's program. But there are opportunities during the year, if you get a good grade in your first year, to go back on the MEng program. And it was the best thing that's ever happened to me because I was able to grow at the university. I met really great people, really great tutors. I was given a guardian because I was 17 when I started. Usually people come in at 18 to university in the UK. So it was nice that even though I was far away from home, I was just thrilled that my parents could entrust me with that opportunity, and to pay for it as well. It's not very cheap. It's not cheap at all. So I felt really privileged, and I just wanted to make the most of it. So whatever opportunities that were recommended to me, I just took them, and I just kept taking them and just going with it, whether I was volunteering. If they said, oh, you're too shy, you need to improve this. Okay, how can I improve that? And I really focused on my academics because it was important that I graduated with really good grades. And then when I graduated, the university offered me a full scholarship to do my PhD. So I ended up not doing the master's in the end and just went straight to my PhD. And I started my PhD in 2011 when I was 20. And I finished and graduated in 2016. And I've been working from 2014 ever since then. So I started off working as a graduate engineer in designing electrical services for buildings. So, and it's just grown from there. But no, I feel very grateful. If I close my eyes and I was like young and 13, and when I made the decision that was what I wanted to do, I couldn't have imagined everything else that's happened since then. And I never forget it. And I hope to someday, put these skills I've gained from here and my experience here to Nigeria, because I remember writing that in my personal statement that you write to universities. I wrote about how I want to improve the electricity and the power sector within my country. That hasn't become a reality yet, but it's something I don't lose sight of. And occasionally, I always try and make connections back home and see how that can become a reality. But at the moment, it's not as simple as it as I thought it was going to be. I thought once I finish my degree, I'm going to go back and everybody would have electricity. Well, the older you get, you realize it's not as straightforward as that, but it's still an ambition of mine, and it's something I hope to do in the future. But yeah, that's how I got here, and that's where I am now. And yeah, I got excited about sensors because it related to my PhD and the experience of working in construction. It just came together in this current role, and I enjoy what I'm doing as smart assets lead. Yeah.
Dr. Isu, thank you so much, and for taking us through your journey and all the things you do. And thank you for everything you are doing and your team is doing to better the world, to make things more efficient, to get our environment a little bit cleaner in that, and just to, again, to get people that energy that we love. We like our TV and everything else, right? It's nice to be able to have those things and have less of an impact on the world and environment in a negative way. So, but we can't thank you enough for your time and being so gracious and willing to talk across the ocean. But I hope you continue to have a great day and a great holiday. And, you know, if you ever need anything from us here in Chicago in the United States, we'd love to support and help as best we can.
Thank you very much for having me. And it's been a great pleasure.